So what is software-defined WAN, wide area network? So SD-WAN is a software-defined approach to managing the wide area network, right? So basically there are three different implementation of software-defined networking. First, SDA, software-defined access or SD access used in campus network. Controller-based solution, controller used in SDA is DNAC, digital network architecture controller. ACI, used in conjunction of data centers, right? Next is 9K, is spinal leaf. And controller used here is EPIC, application policy infrastructure controller. And the third solution or the third component of software defined networking is what? SD-WAN, software defined WAN. So SD-WAN is one of the SDN implementation for the wide area network. So SDA, this one is for campus network, ACI data center, and SD-WAN is for the wide area network, right? So SD-WAN is cloud delivered overlay WAN architecture connecting branches to data center and multi-cloud environments through a single fabric, right? And this Cisco SD-WAN solution solves many critical enterprise IT problems. We are going to understand like them in fact. So basically SD-WAN is completely different than the traditional wide area network solutions, right? Because like there were too many issues in traditional WAN solution, and how this SD-WAN is going to address them, I'm going to explain them, right? So hang in there. So like in next 10 to 15 minutes, you'll understand like the benefits of SD-WAN solution, software-defined WAN solution. Okay, so SD-WAN is cloud-first architecture that separates data and control planes managed through the Cisco Vmanage console. So basically SD-WAN decouples forwarding plane from the data management plane. And let me, okay. So I hope you understand like different planes in networking, like data plane, management plane in general, and control plane. So let's not talk about this SD-WAN solution. In general, first understand what is data plane, management plane, and control plane, and then we will be back to this SD-WAN solution. How like the both forwarding plane and control plane have been decoupled, and how they both are connected with each other. I mean, like what about the reachability between them? So I'm going to explain that, but before that, let's first understand what is data management and control plane, right? So data plane means like user traffic that passes through the device, any device like the firewall, network, router, any device, traffic that passes through the device is what? Data plane traffic. User traffic. Management traffic means like traffic for the management operation. So if a device has a dedicated management port, let us assume that we are managing the device from HTTPS like the web browser or SSH, right, to the management port. It means management traffic is a kind of management traffic, right? Of course, traffic is bound to not bound to like pass through the device. Basically, it's to the device only, to the device, and just for the management operation, for the management purpose, like doing some configuration from the web UI or maybe from CLI like the SSH. So that's what management traffic is, or management plane traffic is, right? Uh, Most of the firewall devices and other devices by default they allow they allow management operation protocols, right? I mean, like incoming traffic coming to the management port is allowed if it is like SSH or HTTPS or ping even, like. So minimum like 3 protocols, SSH, HTTPS and ping, are allowed to the device management interface, management traffic, right? Because mainly they are used for the management purpose, management operation. So management traffic means like management plane is like to handle the management traffic. User data means data plane traffic, traffic that passes through the device. And what about the control plane traffic? So control plane traffic is like device traffic that is originated from the device or to the device itself, right? For example, in switches, in fact, spanning tree protocol is like what control plane traffic or maybe routing updates. Here, like in SD-WAN, we are going to talk about BFD, OMP. They all are what control plane traffic, right? So of course, control plane traffic can be layer 2, layer 3, but control plane traffic means traffic originated by the device itself or destined to the device, right? So that's what control plane traffic is. Control plane. So basically, in general, there are 3 different planes: control plane, management plane, and data plane, right? But they all are in the same chassis, in the same physical enclosure. Even if you have ever worked on like a Nexus 7K or maybe Cisco Catalyst 4500 series switches, 6500 like 6509, you must be aware with the soup like the brain or supervisor, soup card, input, output or line cards, right? So in like let's say 6509, so there are 9 slots here, and soup 1, soup 2, supervisor means the brain, like the control plane sort of thing, and then line card is like your forwarding plane or data plane. So completely isolated, but they both are in the same, and even management plane, the management port, in fact, in the same chassis, same physical enclosure, right? So even if like different planes are completely isolated from each other, but still usually they all are in the same chassis, in the same physical enclosure, right? But here in Cisco VIPELA or SD-WAN solution, that's not same, right? Here, control plane, management plane, and forwarding plane or data plane completely isolated, separated. In fact, they all are not in the same chassis, right? Okay, and I'm going to explain that also. If they are not in the same physical enclosure, same chassis, then how they will connect with each other, how they will communicate with each other, right? That's very interesting point to understand here in SD-WAN. Because if like different planes are not in the same chassis, in the same physical enclosure, how they will be interacting with each other, how they will be communicating with each other. So that's what we need to understand here, right? Because there has to be some transport like internet, MPLS, 3G, 4G, LTE, any transport. And like SD-WAN is like one of the like benefit of SD-WAN is it's a transport independent solution, transport independent WAN, right? No matter what the transport is, there has to be reachability. But what kind of transport we have used, SD-WAN, nothing to do with that. SD-WAN has nothing to do with that, right? So we are going to understand that also. So I hope at least you understand now what is control plane, management plane, and data plane, right? Most of the devices, they all are in the same chassis, in the same physical enclosure. As far controller is concerned, configuring devices with the controller, because it is one of like important feature of SD-WAN. Of course, one aspect is what centralized management and configuration. I mean, like in SD-WAN solution, if like there are 500, 200 or 100 devices, so really we don't need to manage them individually, right? If there are 100 WAN edge devices, so they all can be managed from a centralized controller, centralized management server. It is one like a benefit of SD-WAN. One aspect is what? Centralized management configuration, and configuration, of course we can do like complete management from here only, from the centralized management server. But is it new feature, centralized management? No, right? Why? Let me give you some examples here. uh, in checkpoint firewalls, there is centralized management server, SMS, security management server. So if you have 50, 100 or 200 firewalls, like security gateway devices, so what we do, we create security policies from a centralized management server. This one, SMS, it is known as SMS, a centralized management server, you can understand. We create security policy from here. If similar policy or very same policy is required to be pushed to all security gateways, then maybe in a single policy package, right? A kind of template, different security rules, then different policy package. And once it is created, then what we do, we push the policy from this centralized management server to different gateways. So gateways means a network security device, right? Where like all encryption, decryption, inspection, controlling traffic, VPN termination, everything, routing, QoS policy. So basically data plane and control plane is still, they both are in the same device. Management plane, yes, is separated, is decoupled, right? So for easy management solution, already like we have this kind of solution. Already we have this kind of solution, like a centralized management server to manage multiple gateways. Even in Palo Alto firewall, there is a centralized management server, Panorama. From this centralized management server, we can manage different Palo Alto firewalls. We create policy and then we push policy to the different gateways. Template-based configuration, right? In FortiGate firewall, and even like in some other solutions, Cisco Firepower management server, FMC is another example. So SD-WAN, of course, in SD-WAN, there is a centralized management server known as Vmanage. So from a centralized management server, what we do, we manage basically different WAN edge devices. It means from this centralized management server, we just even create a template. We do a configuration of routing protocols and some other configuration. Once done, then we push configuration from this management server to the WAN edge devices, right? But it is only one feature of SD-WAN, and of course it's not very unique feature, right? You understand that it's not very unique feature. If I say, okay, SD-WAN, in SD-WAN, like there is a centralized management server, you just go there, create template, I mean like the configuration. And even in case if policy, you want to create policy, then policy is also created from there. And then like either policy directly push to the WAN edge devices, or maybe to another controller, that is vSmart. I'll talk about that, and then vSmart will push it down to all the WAN edge devices, right? So definitely it is one of the big advantage or benefit of SD-WAN solution, that is there is centralized management server, centralized controller. But only is one aspect of like SD-WAN solution, centralized management server, or the single dashboard from where we manage all the managed devices. Because like similar kind of solution already we have, like in security devices and some other devices. So it's just one aspect of SD-WAN. So what are the other benefits of SD-WAN apart from like this, like what we have understood up to this point, up until like what we understand, that is, yes, SD-WAN means a controller based wide area network solution, right? controller, and mainly we are talking about a management server. Management server from where we create like templates. I mean, like if you want to configure any routing protocol on any WAN edge devices like OSP or BGP, you really don't need to go there. In fact, you don't need to SSH into device and then doing the configuration. No, from here, like from the management server itself, if they are managed with the management server, then very easily we will do this, right? And I will show you in the lab also how to create template, how to push the configuration. So one aspect is centralized management and configuration, policy, of course. What are other benefits? Okay. So in SD-WAN, you can quickly establish an SD-WAN overlay fabric to connect data centers, branches, campuses, and co-location facilities to improve network speed, security, and efficiency. So another advantage or benefit of SD-WAN is, if let's say an enterprise like has 25 or 30 locations they are connected, and 2 or 3 new locations like are going to be added. So if I'll talk about this like ZTP and PNP, in fact zero trust provisioning are plug and play. So believe me, like either with no configuration at all or very minimum configuration, 3 new sites or branch locations will be up, right? Either with no configuration or just very minimum configuration, right? I'll explain later on like what is ZTP or PNP sort of thing, how like the WAN edge devices will be auto configured, right? Of course, like they need to contact the controller, but how they will be reaching to the controllers, zero trust provisioning or PNP. So you understand like the power of SD-WAN, in fact, because if a new site is needed to be added to the enterprise like the network, so really you don't need to go there, you don't need to send any engineer to the site, right? If PNP as ZTP is supported, then just power on the device will obtain IP configuration from the local DHCP server, and if there is internet connectivity, their proper DNS name to IP resolution, and I'll explain like all the step-by-step process, bringing up the controllers and the WAN edge devices, GTP, PNP. So hang in there, like maybe in the next or next to next module, we are going to understand in detail like bringing a process of the controllers, WAN edge devices, GTP, and if manual configuration is required, then what kind of configuration would be required? Like, so I will explain that, right? But for now, you can understand that WAN edge devices, they will join SD-WAN network either with the minimum configuration or no configuration at all, right? SD-WAN decouples the forwarding plane from the control and management plane, right? So SD-WAN decouples the forwarding plane from the control and management plane. Let me explain this point in detail.